Innate immunity. Following introduction, now we are moving into the course material. First, we'll move with innate immunity. Innate immunity. It's a first-line defense. You can see here how it works. Mechanism. Prior to that, it's a older phylogenetically. It's a first defense mechanism existing. It exists before react immediately after contact with pathogen. So its action is rapid, are not enhanced upon repeated contact with pathogen. So there is no memory. It's just a first-line defense. React predominantly to infectious agents. First-line defense, stimulate and shape adaptive immunity later on. So components of innate immunity, what do you think? First-line defense, epithelial barriers, skin and mucous membranes. Cells are also there. Phagocytes. What are the phagocytes? You know, neutrophils, macrophages, and new one, natural killer cells, that is NK cells. Humoral component. It includes secretory part and complements as well as cytokines. You will learn separately in this matter later. So functional epithelial and innate immunity. It's a physical barrier. So it has physical means of barrier as well as it secretes different microbial peptides. So it's act as a chemical barrier as well. So you can see peptide antibiotics act against these invading pathogens. Then there are in the epithelia, they are contained intraepithelial lymphocytes. It has also antigen recognition and function on later on. And it includes most important normal flora as well. So about the cells of innate immunity, cellular, I said earlier, monocyte and macrophages. Main actions are phagocytosis, inflammation, provoke or initiate inflammation. Later on, T cell activation and goes for tissue repair as well. Neutrophils, it mainly phagocytosis and initiate inflammation. Natural killer cells, killing of infected, mainly viral infected and intracellular pathogens, or act on tumor cells as well, foreign cells. Dendritic cells, it causes phagocytosis, activation of naive T cells as well. It acts as an antigen present in cell, mainly goes with innate as well as adaptive immunity. Mast cells provoke inflammation, eosinophils, defense against parasites. That's why following parasitic infection, see eosinophilia. Role of phagocytes in innate immunity. Order of events in infection. First of all, pathogen should enter. Once entered, pathogen must be recognized by body cells. Otherwise, we may act. If we recognize as self, no action. If it is non-self or foreign, then body react against these invading pathogens. So macrophages and dendritic cells play key action on here. So how do those cells, macrophages and dendritic cells, recognize them? For that, those pathogens also possess molecular patterns. Mainly it's called pathogen associated molecular patterns. So those cells contain pattern recognition receptors, ERR. PAMs, molecular associated membrane patterns. So LPS, it's a PAM. Okay, so it acts as lipopolysaccharide. It's a molecular pattern. Pathogen recognition, molecular patterns, PAMs. So these PAMs are structures common for certain pathogen classes of pathogens, essential for their life, replication or infectivity, not present on human cells. Some examples, bacterial cell wall properties like lipopolysaccharides, peptidoglycans, flagellines. In nucleic acid of pathogens, double-stranded RNAs, unmethylated CpG dinucleotides. Likewise, there are several. So recognition is in pathogens. Then phagocyte, once it's recognized by body cells as pathogens, it's initiate phagocytosis and killing of the pathogen. In innate immunity, it's macrophage as well as neutrophils. So they release reactive oxygen species, so free radicals, as well as another pathways, nitric oxide driven and lysosomal enzymes. These are secretory pathways. There are other pathways as well when you go on NK cells, perforin, fast ligands. There are several triggering apoptosis pathways. So once pattern recognized, now phagocytosis is initiated by the cell membrane of this macrophage as well as neutrophil. So it leads to ingestion of the macrophage, ingestion of the pathogen by macrophage. Then there's a phagosome. It's term phagosome, where this ingested material within the phagosome, and lysosome also they are in the secretory granules. Then phagolysomal fusion happening, and ultimately it goes for phagocyte activation by the secretory cytokines and action of reactive oxygen free radicals, nitric oxides, they leads to kill these pathogens and excrete out. Further, it leads to provoke or induction of inflammation. So once these steps has happened, now time to time there are secretory molecules, cytokines. So induction of the inflammation. So it leads to patient feels discomfort, fever, as well as if it is a local vicinity, swelling, warm, tenderness, likewise. So for that, production of pro-inflammatory cytokines by mainly macrophage, tumor necrosis factor, interleukin-1, IL-6, and other chemokines are there. So once the microbes there, macrophage is phagocyte, it secretes, it activates macrophage. Now activate. It secretes TNF alpha interleukins, and it's provoke inflammation by means of chemotaxis, diabetes from the blood vessels. So these are the pro-inflammatory cytokines. Once it sequentially goes, now it leads to attraction of cells to infected site for action. So for that, there are adhesive molecules like selectins, integrins, and chemokines. So looks how it happens. Here, once the inflammatory process is going on with the presence of pro-inflammatory cytokines, there are adhesion molecules. So, but in a normal state, weak binding and rolling. But when the presence of integrins, it leads to activation and firm binding of polymorphal nuclear leukocytes of macrophages. Now it has a firm binding. With the various adhesive molecules, it leads to transmigration of diabetes. So from intracellular to interstitial space. Because most of the inflammatory process or infection battle is going on in interstitial space. Arrival at the site of it. So it's the chemokine, presence of chemokine, chemo attraction, it's going on. So for a therapy, for example, for rheumatoid arthritis, there are TNF blockers, like VLF4 blockers in multiple sclerosis. So they are pro-inflammatory cytokines. Once attracted, pathogen elimination and adaptive immunity activate. Here, early in killing, and as far as concerned in the innate immunity, they do. But later on, adaptive immunity also activated. So same thing, it's proceed like cascade manner. Cytokines, co-stimulatory molecules, they are. So when we learn about adaptive immunity, we learn further. Then later on, tissue repair and remodeling. Also macrophages play a key role. Tissue factor secretions, enzymes and cytokine like growth factors, metal proteinases. We'll talk about NK cells in innate immunity. It's a cell in innate immune. It's a natural killer cell. So I said earlier, it's virally infected cell they act on and kills, and also tumors. At the same time, they provoke activation of macrophages. Usually, macrophages, phagocytes, they secrete interleukin 12 and axon NK cells. In turn, they secrete interferon gamma and further activate these macrophages. There is a co-stimulatory pathways act each other. So once initially macrophages activated, secrete IL-12, then interferon gamma is secreted by NK cells, further activated and leads to enhanced killing. There is a balance of this. So if it is activated, no killing, NK cell is inhibited. Other way, NK cell is activated. Now it goes for killing. Always there is a balance. It depends by MHC molecule. So further, in a normal or healthy state, here it's an infected cell. It possesses proteins called major histocompatibility complex 1, MHC1. MHC1 is in all over the cells. MHC2, they are in antigen present in cells like macrophages, dendritic cells, likewise. So here, MHC1 is there. So once it's a normal healthy state, NK cell comes and there is a co-stimulatory or other way inhibitor receptor binds and feel that it's normal. Flag is there. We are safe. NK cell is not activated, no killing. But once virally infected cell is virally infected, this MSC class will one protuberance, so flag is unflagged or disappear. Now once NK cell comes and search for this, and they feel no, now it is no, there is some change has happened. That's a signal. Understand the remarkable nature of the nature, mother nature. So now that feel there is something wrong. Now NK cell will acts on there and killing no infected cell. Tumor cells also, once tumor cells, they don't possess MHC1. That's how it goes on. Same manner. So then, similar to not only tumor cells, but also for other infected cell virally, now NK cells, I said earlier, apart from those reactive oxygen free radical mediated and nitric oxide mediated action against by phagocytes such as macrophages and neutrophils, here NK cells, they secrete perforins and leads to perforation of these infected cell or tumor cells, and they secrete granzymes, toxins, like one way. It happens when there is a binding, fast ligand binding. That's how they trigger. Always to happen something, there is a message or binding. Otherwise, they won't secrete. But if it is they secrete, it's a disease. Because always there is a signal. Communication is there. So that is the cellular arm of humoral mechanism of immunity. About the cellular arm of innate immunity. Now about humoral mechanisms, complement cytokines, other plasma proteins, CRP, mannose binding leptins like there are. So we'll learn separately about the cytokines. For a moment, I have discussed earlier. That's how it's about this humoral arm going on. They are coexist. They are always holistic system. So I said earlier this about this relationship. So there are antivirals are made upon interferon gamma, interferon alpha, beta, like interleukins for the therapies given. So once initially innate immunity is activated, there's a bridging to adaptive immunity. So for that, there are signals. First signal, antigen recognition, and second signal derived by innate immunity. Same time, once infection is going on, adaptive immunity also sense this. With the presence of antigen receptors, so antibodies on the lymphocyte, they feel. Same time, there is a signal from molecule produced or induced by microbes. Innate immunity are signal 2. So there's a 2 signal. Leads to lymphocyte proliferation and differentiation in adaptive immunity. That's how it goes. You can see the answers here. Thank you.